Hi guys, me again. So I got some water. It's very delicious and in a nice big cup, so I'm well hydrated. Even though it's still technically spring break, it is very hot out here. It makes it feel like summer. So this next section might be actually pretty easy for a lot of you guys because it goes over briefly about Pythagorean theorem, which we went over before school was immediately closed due to what was happening. So for a lot of you guys, Pythagorean theorem, this formula should look very familiar. A squared plus b squared equals c squared. And again, this formula applies to right triangles. The Pythagorean theorem will not work for any triangle except for right triangles. So to put it simply, when we have numbers that when we plug in for a squared plus b squared, combine those together, the result should be the same thing as c squared when we plug in the last number. If you don't seem to recall, then here's a basic layout for it. 3 squared plus 4 squared equals 5 squared, which when we square it, 3 squared is the same as 9, because 3 times 3 is 9. 4 squared, 4 times 4 is 16. And lastly, 5 squared, or 5 times 5, will be 25. If we were to do the math, 9 plus 16 would equal 25. So this statement would be true. So Pythagorean theorem works basically to remind us how we can find one of these missing letters values if we're only given 2 of them. So, but that's not really what we're here to review, at least not entirely. We're going over the topic of Pythagorean triples. So for some of you geometry kids, you may have gotten a crash course in this during class before the school closed, but in case you haven't, here's a reminder or a beginning lesson. Pythagorean triples. It's not necessarily finding the value of one of the lengths, more like proving that 3 numbers that if you plug into the Pythagorean formula, if that formula result is true, then the set of numbers is labeled as a Pythagorean triple. For example, 3, 4, 5. Those numbers right there would be classified as the fundamental Pythagorean triple set. Because when we plug in 3 for A, 4 for B, and 5 for C, by the way, the order in which the numbers are written in the parentheses determine what they will represent. So the first letter will always be A, the second letter will always be B, and the third letter will always be C. So don't let that confuse you. So if the numbers in that order, when you plug them in for A, B, and C in this formula, if they equal true, much like they did here, then the resulting set is a Pythagorean triple. If they don't, if the result is inconclusive or untrue, then the set is not a Pythagorean triple. Here's another hint for you, just in case you guys get a little mixed up with this. So take a look at this triangle 8, 6, and 10. So, sorry, my neighbors are a little noisy. So if the standard basic would be also to plug it in for A, B, and C. So 6 is A, 8 is B, and 10 is C. If we plug it in, that's going to be true because 36, 6 square, plus 64, 8 square, equals 100, which is 10 square. That is true. So 6, 8, and 10 are a Pythagorean triple. But here's something also to keep in mind. If you look over here, then there would be some similarity between the triangle that is 3, 4, 5 to 6, 8, 10. This symbol right here actually means proportional or proportional in value because basically this triangle is expanded into a larger one. Don't believe me? Check this out. When we take the side 3 of this triangle and multiply it by 2, we get 6. For 4, multiply it by 2, we get 8. and then 5 multiplied by 2, we get 10. So what happens is we take our standard triangle that we know is fundamentally true, and then we doubled its value by multiplying each of its sides by 2. So 6, 8, 10 is that same triangle, but doubled its size. You can also even apply it right here. 3 times 2 becomes 6, and then that little square carries over, and the same for the other numbers. Why am I showing you this? Because this is a nice little hint to show you guys if you are coming across a set of numbers that is actually a multiple of our standard true statement. So just something to keep in mind. So 6, 8, 10 is what happens when we multiply each of these numbers by 2. Another one could be if you multiply each of these by 3, then another given statement for that, if we multiply each by 3, we would get 9, because 3 times 3 is 9, 12, 4 times 3 is 12, and then 5 times 3 would be 15. So that's another given true statement, which is easy to remember because it is just a multiple set, or multiplied enlarged set of our true bread and butter Pythagorean triple basic, 3, 4, 5. So that's just something to keep in mind. You don't necessarily have to memorize that, but if you guys can remember that trick, or if it comes naturally to you, you guys can remember this very easily. All right, let's look at another page here. All right, here's an example. Is the set of 4, 5, 6 a Pythagorean triple? Well, 4 and 5 are the smaller numbers, where 6 is the largest. And in that order, we're going to go ahead and plug it in for our a squared plus b squared equals c squared formula. So 4 is a, 5 is b, and 6 is c. So they're going to be plugged in. Now we're going to square them up. 4 squared is going to be 16. 5 squared, that equals 25. And 6 squared is 36. Now, if you look at it, 16 plus 25 equals 36. Is that true? Wrong, because 16 plus 25 is actually going to be 41, which is not equal to 36. So this statement is wrong. 4, 5, and 6 is not a Pythagorean triple, just like it says in the math over here. It has to equal your c squared. The sum of your a squared and b squared, it must, I repeat, must equal the same thing you get when you take c and square it. And here's a little calculator note that Mr. Wilcox made on these set of notes to help you guys remember how to do this on a calculator. Instead of worrying about taking that number and multiplying it by itself, you look for the x squared button on your calculator, and then that will find the square of a number. Here's a display for example 3x squared, that gives you 3 squared, plus 4x squared, enter. The display should read 25. So if you have a calculator at home similar to the ones that we have been using for this, you can use this setup on the calculator to help you figure out if the sum is going to be equal to your c squared. And that's all you're doing for this next sheet is you're plugging in all of these numbers for a squared plus b squared equals c squared. And if the sum of a squared plus b squared equals c squared, then the set is a Pythagorean triple. So you say yes or no. And any work you guys can show would be greatly appreciated. Even though we're a little bit off in school, I will be generally impressed for those who show their work. All right, that's pretty much it for this section. I'll see you guys on the next one. Have a good day. Bye now.